So this is a topic on circular motion, and in particular we are going to discuss the motion of a car on a circular track in different conditions. So the first case is when a car is going on a circular track. A car is going on a circular track and we want to study what will be the dynamics of this motion. What I mean by that when I say that dynamics of the motion is that we want to see what are the force equations and what will be the maximum velocity allowed on the circular track to a car or to any vehicle. So suppose that this is a circular track with center here at O, and the radius of this circular track is R. And now suppose that our car is going on this circular track with a constant velocity, with a constant speed v, and velocity will be always different because it's changing direction all the time. That's why its velocity will be different all the time, but speed will be same because this is a uniform circular motion. The car is moving on this circular track uniformly. So this is a special case of circular motion, and that is uniform circular motion. We are not talking about non-uniform circular motion, because most of the question that you are going to face in the examination will be from uniform circular motion, and there will be some percentage, 5 to 10% of questions are from non-uniform circular motion. So I am saying that this is so this is a particular special case of circular motion, and that is uniform circular motion. So we are saying that this car is traveling on a circular track with a speed v, constant speed v, and the radius of this track is r, and we say that mass of the car is m. And since we know that this car is, if we draw the free body diagram of this car, so we know that there are the weight is always acting towards the center of earth. This is, we know that all the time this is going to happen, that weight of the car will be towards center, and this is the label surface. This circular track is labeled plain circular track. Labeled means there is no inclination. Labeled circular track. Labeled. I hope that I am spelling it right. So this is normal force that will be acting on this car by the road, and since this car is going on the circular path, that's why there will be a force, centripetal force, and this force has to be supplied by any real force. Like what could this centripetal force be applied by? What real force there could be that can apply this centripetal force? And we know that, however, that our road is rough. A road will be always rough, so we can say that this centripetal force can only be supplied by a frictional force. So the frictional force must be equal to centripetal force. This is the force that can be applied as a centripetal centripetal force Fc, and its value should be mv square by r. And we know that friction force F, we note that this friction force F should be mu times n. And since this car is not skidding on the road, this car relative to road is not slipping in the direction of friction, that's why this friction is static friction. So this is the force applied by the road on the car, mu s into n. And we know that this is the maximum value of the force that could be applied by the road. So Fc, the centripetal force, must be always less than or equal to this maximum frictional force, and we can write it like mv square by r, and this should be less than mu s into n. And n from this free body diagram we know that n is equal to weight of the car or weight of the vehicle, mu s mg. So from this we find that velocity should be always less than or equal to mu s into rg. So the maximum velocity on a circular track, what is mu s r g. All these values mu s, r and g are constant for any given road. So the value of mu s will fix for a road, and whatever is the vehicle that is going, the tire of that vehicle, so mu s will be fixed for that vehicle, and a radius will be fixed for the circular track, and g, we know that this is the fixed quantity. So that's why the maximum velocity for any circular track, it's become fixed. This is the maximum velocity that can be attained by any vehicle. I mean, it can differ for different vehicle depending on the value of mu s. So for some vehicle mu s will be different, because mu s is the property of the surfaces in contact. So this is the maximum velocity that is allowed on this circular track. And whenever the vehicle try to goes beyond this velocity, there will be skidding. What will happen, the vehicle will skid outside the road. So it will skid or slip outside the road. So this is the maximum velocity allowed.